Welcome back, Algebra 1, and we're going to look at 7.3, it doesn't work, exclamation point. So in this situation, Noah's having trouble solving two equations. In each case, he took steps that he thought were acceptable, but ended up with a statements that are clearly not true. Analyze his work on each equation and the moves he made. Were they acceptable moves? Why do you think he ended up with a false equation? So again, back to kind of like the target of this thing, we're going to explain why some algebraic moves create equivalent equations and which do not. And so if I come down here and look at this first equation here, looking at the original equation, all the steps are labeled below what he did, and we're going to see if there's a reason why he got the statement at the end that is clearly not true. 6 is certainly not equal to 1. So given the original equation, what changed from an equation? The first part to the second part is he applied the commutative property. Now, just in case you don't remember the commutative property, for addition specifically, if you add two numbers together, the commutative property says it doesn't matter the order that you add them. So 2 plus 3 and 3 plus 2 are really the same thing. Or 2 plus 1 plus 3 is the same thing as 1 plus 2 plus 3, which is the same thing as 3 plus 2 plus 1. In other words, the order when you add numbers doesn't matter. And that's what the commutative property says. Those are all equal to each other. So in this case, what happened is the 1 minus 3x became negative 3x plus 1. And then after that step, it looks like they combined like terms. So down this third equation here, we now have an x instead of having a 4x minus 3x. And then finally, they subtracted x on both sides to get 6 equals 1. So first of all, are all these steps acceptable? Well, the original equation is the original equation. Then he applied the commutative property. So if you take 1 minus 3x, that's the same thing as 1 plus a negative 3x. When you're adding, again, the order doesn't matter, so you can swap that to negative 3x plus 1, because again, this one's positive. So that actually is an acceptable step. You can switch the order of addition because you can rewrite subtraction as adding an opposite, and as long as the minus comes in front of the 3 and the plus comes in front of the 1, we're okay. So the next step is they said you combine like terms. They had 4x's, take away 3x's. That's going to give you 1x, which is the same thing as x. So that's actually acceptable too. And then finally, subtracting x on both sides. As long as you do it to both sides, that's a reasonable thing. Those x's cancel out, and those x's cancel out, and we get 6 equals 1. So it appears that Noah made all of his moves have been acceptable. But let's look at this second part for a second, because I'm not sure why we're getting 6 equals 1. But if you really take a look at this second to last line here, think about this. If you take any number you can think of and add 6 to it, you'll never actually get the same thing as if you took that number and added 1 to it instead. So whatever x is, you can't add 6 to it and then get the same thing as taking whatever x is and adding 1 to it. That's impossible. So Noah's moves are acceptable. He just has an equation that's impossible to solve. This equation has no solution. There is no real number that can solve this. And I want to show it to you graphically what this looks like, because if I look at the x plus, so this is the left-hand side was x plus 6. The other side was 4x plus 1 minus 3x. The solution of the equation is where the lines intersect. And if you notice, these lines are what we call parallel lines. They'll never intersect. So there is no point where the blue line will ever actually intersect with the red line. This line is always going to be 5 above the bottom line, because again, x plus 1 versus x plus 6 is never going to, you'll never get the same value. So graphically, you can see that they never intersect, but this equation is impossible to solve. It has no solution. So he did make acceptable moves. It just didn't lead to a solution because the equation didn't have one to begin with. Now this next one, again, we're getting a statement that doesn't make sense at the end. But if you look at the equation, the first thing they did is to apply the distributive property. So 2 times 5 is 10, and 2 times x is 2x. So this checks out. That looks like the distributive property to me. And then it says they subtracted 10 from both sides. So if Noah subtracted 10 from both sides, those 10s would zero out, and I'd be left with 2x minus 1. And 9 minus 10 is negative 1. So this side does check out. Subtracting 10 from both sides is an acceptable move. Following that, Noah decided to add 1 to both sides, which will cancel out those ones, but it also cancels out those ones as well. So now we're left with 2x equals 3x. And again, adding 1 to both sides is certainly an acceptable algebraic move. We have a new equivalent equation. And then, to get this final step, it looks like he's dividing both sides by x. So if I divide both sides by x, those x's cancel out, I get 2 equals 3. Now, it turns out that this might lead you to believe that there's no solution. But let me show you what the graphs of this situation looks like. So I'm going to graph the left-hand side and the right-hand side. And again, the solution is where they intersect. So this is the left-hand side of the equation, and this is the right-hand side of the equation. If you notice, they're not parallel. There actually is a point where they're both equal. This intersection point is when x equals 0. So it actually does have a solution. However, what we're led to believe here is this statement here is making us believe that there's actually no solution. Let's just go to the beginning and test the 0 real quick. If x were to be 0, then 5 plus 0 is 5, so this becomes 2 times 5 minus 1, which is 10 minus 1, which is 9. Here, 3 times 0 is 0, and 0 plus 9 is also 9. So what happens here? Because 0 turns out that it truly is a solution, but making seemingly algebraic moves didn't lead me to that. And it's actually this last step here. Dividing by x on both sides is not an acceptable step. And that's only because when you divide both sides by x here, remember in the warm-up, there's only one number you can't divide by, and that's 0, if you remember from right here. We can't divide by 0. So when you get a situation where if you divide both sides by x and x is 0, you're going to get a result that's not true. So this step right here, it's not an acceptable step. We can't divide both sides of an equation by 0. So in this situation here, that's why this step right here is actually no good. So Noah may have been led to believe there's no solution. But x equals 0 is a solution. So I do want to make a note here. Dividing both sides by a variable, it's not that that's completely unacceptable, but if you do it, you have to first check if x is 0. And that's what I kind of did up here in the top. If we plugged in 0, we see that 0 is a solution. So if knowing that x is 0, then we're not going to be able to divide by it on both sides. But in general, we don't multiply both sides of an equation by 0 because then we just get 0 equals 0. We don't divide both sides of an equation by 0 because we can't divide by 0. So everything else we do to both sides is fine. Those are just the two operations that we have to avoid. Anyways, that's it for this video. Make sure to like, subscribe, smash the like button if you like the video. If you have any questions, I'd love to hear it in the comments. And it turns out that only about 40% of my viewers are actually subscribed. So it would really help the channel out. And a quick shout out to this video sponsor, Raid Shadow Legends. Play today. Try the code down on your own. Good luck. And I'll see you guys next class.